Welcome to GoSimulation.com. If you enjoy this video, please make sure to sign up for our email newsletter so that you can receive updates on future videos. In this video, we're going to explore something called the crawl, walk, run system. Now, the crawl, walk, run system is a three-part system which is designed to take really complicated geometry that you have in SolidWorks, and it's designed to simplify that geometry down into something that you can run a simulation on. Then, once you can run a simulation, then you gradually add more complexity to the model in the walk and then run stages of the analysis. The crawl, walk, run system is really just a series of simulations which are designed to take you from having a really simple model to having a more complicated model, and then finally the most realistic model that you can possibly get. So that's the overview of the crawl, walk, run system. This is a bridge which was modeled by Richard Williams. Richard is a teacher as well as a blogger. His blog is called Richard's SolidWorks blog, and you can check it out here. In his course, he's actually going to build this bridge. And ideally, he wants this bridge to withstand a certain amount of weight. Now, in this particular video, we're actually going to focus on the crawl portion of the crawl, walk, run system. And that's because the crawl, walk, run system can be pretty time consuming, especially if there are a lot of parts or if it's a very complicated simulation. So this is going to be a multi-part video series. If you'd like to get updates as we go along, please sign up for our email subscription list, and I'll send you an email when the next video comes out. Now, as I said, we're going to focus on the crawl portion of the crawl, walk, run system. And so what that means for us is that we're essentially going to get to the simulation just to run. We're not concerned about accurate loads or accurate fixtures or anything like that. So with that said, let's go ahead and get started. In a case like this, with so many parts and so many little bolts and nuts and stuff like that within the model, it's actually really hard to get to a stage where you can run the simulation. So when you're dealing with a model like this, the first thing that you're going to want to do is start eliminating parts from the model. Now, if I go up to my Tools drop-down menu and then select AssemblyXpert, we'll be able to see that we have almost 2,000 parts within the model. Now, if I were to go through each one of these parts and suppress them individually, eliminating them from the model, that would be an incredibly time-consuming process. And so what I'm going to do is I'm going to show you a couple tricks that will enable us to just keep the beams. That's all we're going to do, is keep the structure. We're even going to eliminate these components right here, the gusset plates on both sides. So with that said, let's go ahead and get started. Now on the left-hand side, we can see that we're working in lightweight mode. And we know that we're working in lightweight mode because we have a little feather next to almost every single one of these parts. Now, one of the tools that we're going to want to use are the assembly visualization plot. Now, the assembly visualization plot will allow us to organize the parts in our model by mass. And once we do that, then we can see what are the really small parts. And then once we see what are the small parts, then we can actually eliminate them from the model. But as you can see, the mass is not showing up here. And the reason why that is because we're working in lightweight mode. So what we're going to have to do is come back into the model and scroll up to the very top, and we're going to resolve our model so that we're not working in lightweight mode anymore. In order to do that, you're going to want to go ahead and right-click at the top here, and then select Set Lightweight to Resolved right here. And that may take a little time, but that should take the feather off of every single one of these parts. The next step is to go back to the assembly visualization plot. Now remember, that's under the Tools drop-down and then Assembly Visualization. And now, as you can see, we have mass under these components. So now what we're going to do is organize this tree by mass. And the way that we do that is just by selecting this mass right here. Now we want this little caret to be up, so just make sure that it's pointed up and that these smaller components are listed at the top here. Now what we're going to do is we're going to select all of the components that are lighter than 0.15 pounds. And in order to do this, we're going to simply select this component, the weight platform bolt parts, and then we're going to hold down the shift button, and then we're going to select this top component, small hex nut. And this is going to take a little while for SolidWorks to select all of these components. And if I were to click out here or somewhere, it would come up with that error message that says SolidWorks is still working. So what I'm going to do here is I'm just going to pause the video and wait until all of these components have finished highlighting. Now that these components are highlighted on the screen, what we can do is simply right-click and then select Suppress. And that will take most of these components out, or all of these components out, and leave us with the larger components. And if you get this warning message, just click Close. That's all right. Now that we've eliminated all the small components from the analysis, the next thing that we're going to do is eliminate some of the bigger components. Now, when we run this simulation, we're going to run this simulation with beams. And so what that means for us is that we're not going to have any solids within the analysis. Beams within SolidWorks Simulation are long, slender members. And so everything that's pretty much a long, slender member in this whole model is going to be kept. And anything that's like this gusset right here or this box, we're going to eliminate. Now with this box, because there's only one of them, I'm actually just going to go ahead and from right to left select the box and then right click and then suppress. And then click Close to this warning message. The next thing that we're going to do is eliminate the gussets. Now the way that we're going to do that is by using this search tool up here. And because all of these gussets are named gusset, we can just search gusset, and then what's left are all of these gussets right here. So what we're going to do is just select all these guys. If you'll notice, there's a bit of a bug right here. I'm not sure what that's about. And then we can right click and then select Suppress, and it should eliminate all of them. Okay, now what I'm going to do is just examine the model and make sure that the only thing that's left are these beams, these structural members. Just a real quick examination of the model, and I can't see anything at the moment. So what I'm going to do next is actually create the simulation. Oh, nope, right here. We have 4 more gussets, and these are called end plates. So we'll just do another search here for plates. And these 4 plates right here are going to be eliminated, so right click, suppress. The next thing that I'm going to do is I'm going to create this simulation. Now normally what I like to do is make sure that I have 3, maybe 4 bodies max when I create my first simulation when I'm in the crawl phase. And I do that when I have shells and solids. Now because we're working with beams, it's a slightly different case. And that's because what you can do with beams is you can edit the joint groups. Now remember, a joint occurs at the end of a beam, and once 2 beams sort of meet up and their joints seem like they're going to intersect, those joints will merge as one and create one joint. And when working with beams, you can edit or manipulate the joint groups to make your model a little bit more stable. And that's what we're going to do. So beams are a little bit different. You can have a few more components when working in the crawl phase of a simulation when you're working with beams. Now, in order to get started with the simulation, I'm just going to come up to the Simulation tab, click the drop down, and create a new study, which I'll call Crawl. And then I'll click OK. Now, like I said, we have quite a few bodies within this simulation, but all of these bodies are currently being treated as solids. And you know that they're being treated as solids because it has this symbol. So what we're going to need to do is take all of these bodies which are being treated as solids and right-click and then treat as beam. Now, if I scroll down, you'll see that we have quite a few bodies to do this for. So I'll show you a little bit of a trick. All you have to do is select each component, hold down the Shift button, and then select the next components. I recommend doing this with all of the solid bodies. I don't recommend doing this with the parts right here. Then you right click, and then you can bulk do this with multiple bodies here. So you can treat selected bodies as beams. And once this goes through and these are all treated as beams, what we'll do is we'll scroll down and do the same thing for multi-bodied parts here. So I'll just shift select all of these components, treat selected bodies as beams. Do this for this one, and I'll just go a little bit faster now that you know how to do it. Now, excuse me if I'm going a little bit too fast for you, but this particular video is more of an advanced video. So I recommend that you have some experience working with SolidWorks Simulation when you're doing a video like this. So I'm just going through all of these bodies and treating them as beams. Doing it here too. So this is quite a bit of a time-consuming process, but you have to consider how many bodies we're actually working with. It's a lot. So there is no real fast way to run a simulation with maybe even 100 bodies or however many bodies we have here. But this is about as fast as you can possibly go. So now I think that I have converted all of the solid bodies as beams. I think so. I may have missed some. We'll know for sure down the road. The next thing that I'm going to do is just edit the joint group. So I'm just going to right click and then select edit. And now what I want to do is that I want to select this less than option, because if I don't, and if I just select this equal to option, that means that in order for two components to be sort of locked together at a joint, they need to be touching. And I have very few components that are actually touching. And so instead what I need to do is I need to select this less than option. And what this will do is it will create an orb, an imaginary orb, around the ends of these beams. And if this orb is intersecting with another beam's orb, those two orbs will sort of merge together and join as one. Now, right now the orb size is about 1 meter, and that's a little bit too big. I'm just going to switch this over to 0.2 meters. And then I'm also going to select this option, Keep Modified Joint on Update. And now what I'll do is I'll click the Calculate button, and that should create joints just about everywhere that I want them to be. Okay, so now what I'm going to do is I'm just going to view the simulation joints. As you can see, I'm hiding them right now, and show them within simulation. I'll just click the OK button, and you'll be able to see the pink joints. Now we can go back in and edit these joints if need be. I guarantee they're not going to all come out very well, but I'm just going to go ahead and right click on joint group again and select edit. If a particular joint group is not including the beams that you want them to include, what you can do is you can right click on the joint and that will show you all of the beams that are associated with that joint group. Now once I right-clicked on this joint, it selected all of these beams. It selected 4 beams, and that's actually too much. So what you would normally do is unselect these guys, and then now this joint is just considering the bonding of these 2 components, which is what we really want. But we don't really care if the joints are operating that well at this stage in the analysis. That would be more for the walk or the run simulation. And because we're in the crawl simulation, we really don't care all that much if the joints end up correct. We just want a simulation that runs. So with this said, what I'm going to do is just exit out of the Edit Joints command. And now what I'm going to do is I'm just going to set up a really simple simulation with just fixtures and a load. And if this simulation runs, that's how we know that I've gone past the crawl phase. Because remember, the crawl phase is just getting a simulation to run. That's all that it is. So I'm just going to select these components, and I'm going to fix them, but allow rotation, and then I'm going to click OK. And it doesn't even really matter how I'm setting the model up. I'm going to apply a force here, but it doesn't really matter how I apply the force or in what direction or anything like that. All I need to do is just set up a simulation that runs, and I don't care about anything else. And I'll click OK. So now I have a fixture, I have a force, I have my beams, and I have a joint group. Now what I can do is just click Run, cross my fingers, and hope for the best. So I'm getting an error message that says the elastic modulus in material properties is undefined. So what I'm going to do, again, I don't really care about what sort of material I apply because that's going to come in the walk and the run simulations. So what I'm going to do is just keep it really simple. Right click, apply alloy steel, and then close. I think this bridge is actually going to be made out of wood, so that would be later on down the track. Now that I've reapplied the material, I'll just click Run again. Again, cross my fingers, hope for the best. Well, it meshed. And now it's running. And if it fails, that's how I know I'll need to go back and I haven't passed the walk or the crawl simulation. But it didn't. It actually finished and it ran. Now I'm just going to go ahead and hide the joints, and I'll see my results. My results aren't looking terribly good right now, but that's okay. I have a simulation that runs, and I've done it in probably under 20 minutes, which is a complete success. So the next stage would be to make the model more complicated in the walk and then in the run simulations. But for now, we've gotten the model to run, and so we've passed the crawl simulation. This is a multi-part video series, so if you'd like to get an email update or an email reminder when I release the walk and then the run simulation videos, make sure to sign up for our email newsletter. Thank you and have a great day, and thank you for visiting GoSimulation.com.